Hello, welcome to this chemical process control lesson, introductory lesson, where we are going to see the two most typical control loops that we can find in the chemical industry. Why do we need control in the chemical industry? Well, the main purpose of having control is to maintain the processes at the desired operational point. So we want to maintain, for example, a temperature in a reactor, because the process is going better or faster at this temperature, and there are many other reasons that we have to need control. We can have operational restrictions of pressure, temperature, flow rate, so we can only work with our system in a very narrow range of operational points. Or maybe we have some product specifications as quality, quantity, and of course low variability of the product. We also have safety regulations that limit the range of value of temperatures, pressures that we can work, and also environmental regulations that will have to meet some discharge or emission limits. And finally, also very important, the economy of the process. Maybe working at a very specific operational point is much better in terms of the economy of the process. So we will want to work at this operational point to improve the economy and also to accomplish all the safety environmental regulations. So the classical definition, general definition of control is a set of operations oriented to supervise the state of a system to generate, as a function of the deviation of this desired state, control actions needed to reduce or eliminate this deviation. So we are supervising a system and measuring something, and based on these measurements we are comparing that value with the value that we want to have there, so that's the set point. And if we detect some deviation, we can modify the process, the operation of the process, to return to the operational point that we wanted to maintain. So this definition is very general, so it includes also, for example, manual control, and this is only very limited validity. And what we are using in the chemical industry is automatic control. So what does automatic control mean? So if we have the acquisition of the information, we have a sensor that is measuring online, and we have this data online, and we can compare the value that we are measuring with the set point also in a controller, and this controller decides the output of the control action that will change the operational conditions of the system by manipulating manipulated variable and input to the system. And all this is done automatically. We will have automatic control. That's the one that we are going to see today. The most usual configurations where we will find implemented this type of automatic control are feedback and feed-forward control loops. Let's see the difference between them. In the feedback control, this is the typical block diagram to describe control loops. You have the process that is subjected to the input of disturbances that we cannot control, we cannot modify, and to also the input to manipulated variables, that these are the ones that we can modify. So we are measuring something that will be this type of feedback control, the controlled variable. We are measuring with a sensor. We are sending that information to the feedback controller, comparing with the set point, and then the feedback controller decides the controller output that acts over the final element, and the final element changes the value of this manipulated variable that modifies the controlled variable of the process. So there are the steps. So the control variable is measured with a sensor. We are measuring the values compared with the set point in the feedback controller. Then the controller decides the actuation and sends it to the final element. The final element modifies the manipulated variable, and the final objective is that the control variable modifies its value and comebacks, returns to the operational point that we wanted to maintain. So if we look to the real elements that can be found in a control loop, in a feedback control loop, we have the measuring element that it displays in the process and sends the information to the feedback controller. So the feedback controller receives this input, and the set point can be changed by the keyboard or send it by another supervisory system, and the controller, based on this information on the set point, decides the controller output. So it acts over a final element, typically is a valve in the chemical industry, that modifies the flow that is introduced in a process. This can be, for example, the temperature measurement, and this can be the flow of a cooling system that modifies the flow through a reactor that the final purpose is to maintain, to remove the excess of heat of the reactor, to maintain a desired value of temperature in the reactor, even if we are subjected to some disturbances, changes in flow or temperature in the input. On the other hand, in the feedforward control, the idea is very different. In this case, we are not measuring the controlled variable. We are measuring the disturbance with a sensor before entering the system. And then with this sensor and with the set point of the controlled variable, the feedforward controller decides the action to counteract its effect. So we have to have a good model here that calculates based on the disturbance, the value of the disturbance, and the desired value of the control variable, which will be the best output, that when the final element receives this value, it changes the manipulated variable and receives the order and modifies this value to minimize the effect of the disturbance. So even in the case of disturbance, we are able to measure, for example, a disturbance in flow. We could measure it with this flow meter, send it to the feedforward controller. The controller then decides the output and sends the order to the valve, and then the manipulated variable changes, and the process will be able to counteract with the effect of the disturbance. And then if everything is done perfectly, we measure perfectly, and we have a very good model here, we will be able to counteract with the possible effect of the disturbance with another effect, and then finally the controlled variable would then move from the operational point that it was maintaining before. So we are able to remove the effect of the disturbance by acting through the manipulated variable. So now we have seen the two types of control loops, the feedforward and the feedback, and in the following examples we are going to identify the elements of each control loop. In particular, we are going to identify the measured variable, the controlled variable, the disturbance, the manipulated variable, and the type of control loop. So let's see these examples.